Okay, here's your warm-up. I'd like you to find the zeros of each of these functions. Remember, a zero is where your function value, your y value, is equal to 0. Press pause, and when you're ready to see the answer, press play. Okay, so you will notice that I factored each of these and set each of the factors equal to 0, and that's how I got the zeros of my functions. Okay, so what we're going to talk today about is graphing polynomial functions. And what I'm going to lead you through are some things that we want to do in order to help us graph. So I'm looking at the function, I believe, from our warm-up, the first one. And I want to find the x and y intercepts of the graph. So the way you find the x-intercept is you plug in 0 for y. Okay, and if I plug in 0 for y, it's easiest to look at the factored form. The x-intercepts are going to be anywhere there's a 0. So my x-intercepts are going to be negative 3, 0, 2, 0, and 3, 0. The y-intercept I get by plugging in 0 for x. And the place that's easiest to find my y-intercept is looking at the unfactored form, because if I put in 0 for x here, I'm just left with the constant. So my y-intercept is 0, 18. Now, here's some vocabulary. And I'm just going to say this ahead of time. At any point, if you need to pause the video so you can take longer to take notes, please do that as we go. So the vocabulary that goes with this is x equals negative 3 is a solution or a root of the function. So negative 3 is a root of the function. You'll notice that negative 3 is a 0 as well. Okay, these represent the values that make the function 0. Negative 3, 0, you'll notice is an ordered pair. It's an x-intercept of f of x. X equals negative 3 is also a 0 of my function. And then finally, based upon this 0, x plus 3 has to be a factor of my function. So your factors are always x minus the 0. Those are the factors of your function. Now, polynomial functions in standard form go in decreasing order of exponents. So my highest exponent goes first, next highest second, and then all the way down to the constant. The degree of a polynomial is the value of the highest exponent. So in this case, it's n. My leading coefficient is the real number that is in front of my variable with the highest exponent. These are all real numbers. My constant is the value without an exponent after it, although if you're going to be technical, after it is an x to the 0 power, which of course is 1. Now, I want you to open up your browser to Desmos, and I want you to type this function in there, and I want you to see what it looks like. I know you guys have used Desmos before. Let's see if I can get that open. Let's go here. I already have mine typed in. Let's move this over so you can see it a little bit better. So clearly, my graph intersects at negative 3, 0, 2, 0, and finally 3, 0. Up here, 0, 18 is my y-intercept. So to graph our function, it's going to be really nice when I know the zeros in the y-intercept, because that gives me an idea of what my graph will look like. And we are going to keep looking for different identifying features of a graph so we can do a good job with that. Now, The intermediate value theorem says let a and b be real numbers such that a is less than b, and let f be a polynomial function. If f of a and f of b have opposite signs, then there's at least one zero between a and b. Now let's talk about that. All polynomial functions are continuous. In other words, if I started drawing on my graph from left to right, I could draw and never lift the pencil. So here's an example of what this intermediate value theorem is saying. If I look at this value, my y value is negative. If I look over here, I have now found a y value that's positive. So somewhere between this x value here and this x value here, I know my graph has to have intersected this x-axis at least one time. And of course, it's intersected 1, 2, 3 times. Now, let's find another one. If I look here, I have a y value that's negative. Over here, I have a y value that's positive. The only way that I could get my function to go from a negative value to a positive value is if I intersect my x-axis. So I have a 0 there. And that's all the intermediate value theorem is saying. Multiplicity of a 0. If x minus a to the n power is a factor of a polynomial f, then a is called a 0 of multiplicity n of f. This n, this exponent that's on your factor, is the multiplicity. This is your 0, and then x minus your 0 is your factor. So take a look at this function g. I want you to name the zeros and their multiplicities. Press pause, and when you're ready to hear the answer, press play again. Okay, so I have these zeros. 1, -4/5, and -5. The multiplicities are these. 2, because that's the exponent that's on that factor. 7 here, and 1. Now, multiplicities are going to tell us something very nice when we're graphing. You'll see that in a little bit. Now, in Desmos, I want you to graph and change the multiplicities of each zero. Investigate how multiplicity affects the value of g of x between zeros. So take a few minutes, press pause, and then when you're ready to discuss it or hear the answers, press play again. Now, here I've graphed in Desmos my function, and each of these have multiplicity 1. And you'll notice that I have my x-intercepts in each of these places, and my graph passes through the x-axis at each of those points. All of them have odd multiplicities. Now, if I look at this graph, I have changed it so that c, x minus 1, it has an even multiplicity, and you'll notice that when there's an even multiplicity, my graph bounces at that 0. These are odd. It cuts right through, and then when I get to a 0 multiplicity, it bounces. Same kind of idea here. This guy, even multiplicity, odd multiplicity. So I'm going to bounce here. My function is going to pass through this point at -2, and it's going to bounce over here. So, in summary, multiplicity of a 0 tells us a little bit about the graph. If my multiplicity of my 0 is even, f of x on either side of x equals a does not change signs. So what does that mean? Well, let's look back here. Here's my multiplicity. My 0 here is 2, and is my 0 there too? No. My 0 there is 1. The multiplicity here is even. So to the left of 1, my function is positive. To the right of right of 1, my function is positive. However, if I look at a spot with an odd multiplicity, to the left of x equals -2, my function is negative, and to the right, my function is positive. So that's what that's referring to. The graph of the function at the intercept touches the x-axis and turns around at point A0. So in other words, when it's even, my graph bounces. Now, if it's odd, my function changes signs on either side of the 0. I showed you that a few seconds ago. And then if it's odd, it crosses the x-axis at the point. It does not bounce. Now, the other thing that can help us graph is knowing something about the end behavior of our graph. If I look at a polynomial and the degree is even, if I know something about the leading coefficient, it tells me about the end behavior of my graph. If my leading coefficient is positive, my graph will turn up on the left and turn up on the right. However, it's negative, it turns down on the left and down on the right. And the way that I remember this is I think about just my most basic polynomial with an even multiplicity. Even degree. Y equals x squared. We, of course, know that that is a parabola. And on the left it goes up and the right it goes up. However, if I looked at this with a negative leading coefficient, it's a parabola, and it's down on the left and down on the right. And it's just an easy way to remember. Now, if the degree is odd, if the leading coefficient is positive, it's down on the left and up on the right. If it's negative, it's up on the left and down on the right. Now, the way I remember this is just a basic line. This has a positive slope. Y equals x. And of course, that's a polynomial, right? It has a positive slope, down on the left, up on the right. But if I look at this, y equals negative x, it has a negative slope. Oops, I drew it with positive slope. What am I doing? Let's see. One more try. Okay, has a negative slope, up on the left, down on the right. And that's how I remember what the end behavior is of my polynomial. Now, we want to start graphing these polynomials. We found some things out about each of these. I know what my zeros are, and I know what the multiplicities are. So we are going to plot our zeros, and then we are going to think about what's going to happen due to the multiplicity. Press pause, plot your zeros, and when you're ready, press play. Okay, I have my zeros plotted. I did not put the values in here though. This one is 3, this is 2, and this is negative 3. And over here I have 0, negative 1, and positive 4. Now, according to the end behavior, well, first of all, let's talk about multiplicities. All my multiplicities here are odd, so I know that my graph is going to pass through at each of those zeros. Over here, the multiplicity on the 0 is even, so I know I'm going to bounce right there. Now, looking at the end behavior, this is an odd degree, and my leading coefficient is positive, which means that my graph is going to go up on the right and down on the left. So I'll start by drawing that in. It's going to go up on the right, down on the left. Now, the multiplicity on the second graph is even, and my leading coefficient is positive. So my graph will go up on the right and also up on the left. So now I have a good idea about what's going to happen. And because of the multiplicities, I could kind of draw in a basic graph of this right now. I know I'm going to cut through at each of these zeros. So it's going to do something like that. This one I'm going to bounce at the 0, 0. So it'll do something like that. Of course, we don't know how far my graph reaches up and how far it reaches down. And for that purpose, we're just going to have to plug in some values. When you get to calculus, you'll find the exact location where my graph switches from positive over to negative. Now, the next thing that I want you to realize is that my graph has at most n minus 1 turning points. Now let's go back and look at this just a second. My degree is 3. So I'm going to have at most 2 turning points. Now a turning point is when I change from going in a positive direction to a negative direction. So if you watch, I'm going up, up, up. I'm going to turn. That's 1 turning point. Down and back up. There's another turning point. So 2 turning points here. Over here, I'm going to have at most 5 turning points. Now if I look at this, here's 1, 2, 3 turning points. But remember, it's at most 6 turning points. Now, I want to finish graphing this. Now, some other things that are helpful to us have to do with finding the y-intercept. In this case, I know my y-intercept is at 0, positive 18. Now, is this the highest point the graph reaches? I have no idea, but I do know that it's going to go through that point. How can I find out if it goes further up than 18 or not? Well, I have to test some values. Over here, I know my y-intercept is 0, 0, so that doesn't help me very much. So what you're going to want to do is you're going to want to make an fy chart here. So I would pick a value between -3 and 0, maybe -1, and I would find my function value. So if I evaluated f of -1, I would get -3 times -4 times 2. So that would be positive 12 times 2, or 24. So clearly my graph is going to go up past this positive 18. Ooh, I don't like how that looks. And then back down through. Now, I know it's going to be smooth back down through the 2. Now the question is, how low do I hit between the 2 and the 3? And the more points that you find in between these values, the more accurate you're going to be. I'm going to let you figure out a value between 2 and 3. At a minimum, what I want you to have graphed are the x-intercepts, the y-intercept, and I'd like for you to find one value in between each of the zeros to plot. Okay, but for right now, I'm going to draw it like that. I will leave that to you. Same thing over here. I would like a value between each of the zeros to plot to make it more accurate. It may not be the lowest point it reaches. It may reach lower than that, but again, until you hit calculus, you're not going to know exactly how low it goes. So I do know that my shape will look like this. Okay, how low does it get there? It might get much lower than that. I'm going to leave that for you to test. So again, we're going to find some extra points and draw. Now one more task that I want to do today has to do with finding the polynomial given the zeros. And I wanted a minimum degree, and I state what the multiplicity is. Now if you remember, if I know what a 0 is, I know that my factor is always going to be x minus the 0. So this polynomial will be x minus 0, times x minus 1. 1 is the 0, but it's to multiplicity 2. Now what we're going to do is we're going to multiply that out. And then we'll distribute the x. And I want to make sure it's in standard form, so from highest exponent to lowest exponent. And this is my polynomial of minimum degree. Of course, I could make a lot of different polynomials just by multiplying each of these numbers by a constant, and it would still intersect through the zeros, those x-intercepts. So there's lots of different functions that I could write, but this is the minimum degree and the most simple one to do. Now, that is our lesson for today. So let's just go back for a minute and review a few things we learned. We learned some vocabulary associated with polynomials. We know what a solution is. An x-intercept, again, we're writing an x-intercept always as an ordered pair. We know that a 0 is a x value that makes my y value 0, and a factor is x minus the 0. Polynomials, we learned about those. Our standard form is listing it in order of decreasing exponents. The degree is the highest exponent, and the leading coefficient is the number in front of the variable with the highest exponent. The constant is the value with no x. We started graphing, and we learned about the intermediate value theorem. Our polynomial functions are continuous. So if I have a value on one side of the x-axis and a value on the other side of the x-axis, I must be cutting through that x-axis in at least one spot. We talked about multiplicity of the 0 and how that affects our graph. If we have an even multiplicity, our graph will bounce. If we have an odd multiplicity, it cuts through. We talked about end behavior, so that's helpful when we're graphing. And we talked about actually physically graphing these graphs. So you're going to plot your x-intercepts, your y-intercepts, think about the multiplicity and how your graph has to go, and then you will find some extra points in between each 0 to make it more accurate. Now at this point, what I'd like for you to do is look at the assignment on Schoology and get to work on it. And I will see you tomorrow. Have a wonderful day.